Hello everyone, today we will be working on a new dataset. Basically, this is a Kaggle competition, the spaceship Titanic dataset. It is a starter competition for people who are new to machine learning and Kaggle. So basically, what we have to do in this competition is to predict the people who got transported to an alternate dimension as stated here. You can read the competition page to better understand the problem and the data. As you can see, here is the metadata of the data, all the description, all the features, etc. So let's move on to the code. As standard practice, we will first start by importing all the libraries. In this video, my main goal will be to show you uh, how to create new features, or basically from the metadata, how to extract new features. For example, like you can see cabin, we have the cabin data is divided into deck, num, site. So we'll be extracting these features so that our machine learning model can understand better, learn better. And we will be using logistic regression. I want to show you how using simple techniques you can get great outputs. Basically, logistic regression is basic for supervision classification. So basically, we're using that. So let's start by setting np.random.seed to 42. I'm doing so that I get same results. I can recreate the same outputs. So here I am importing the data. You can see the train data. There is our test data. You'll be working on both simultaneously. In Kaggle, you have to have a test data so that you can use that to make your submission for the prediction, basically for the competition. So you'll be start by seeing the column names. You can see we have passenger ID, home planet, cryo sleep. Basically, the people on the ship were they cryogenically slept or not, cabin in which they were, destination where they were going, age, where the VIPs or not, room service, food court, all the amenities that they used or not. So we'll see the shape. We have 8,693 rows and 14 columns. We can see the information here, all the column names, non-null values, data types. You can see that there are some null values available. We have to fix the data types, etc. First, you will start by making the feature extraction, basically feature engineering. As you can see, we are creating new features to get out more information from the available features. So from the passenger ID, I am getting out the group. So basically, as you can see in the metadata, in the passenger ID, we have group and number of people in that group. So I'm taking out the information and the number of people in that group. I'm using .str.split. Basically, I'm splitting on underscore, as I can see in the passenger data that the two values are separated by an underscore. So I'm splitting. I'll be getting both the values, and from the .str, I'm getting the first value for group and second value for my number of people in the group, and I'm making the category the type as category. Category is a pandas d type, so basically it is used for categorical features. You can also use object, but categorical is better. Then I'm getting the deck, cabin number and site from the cabin, and I'm creating a total spending new feature, total spending, basically, which will be a sum of all room service, food court, shopping mall, spa, and VR deck. Basically, all the amenities that people use. So I'm getting all the combined expenditure of a person. Then I'm doing the same for test data, so that there is consistency between train and test data, so that my machine learning model can work on it. Next, I'm getting cryo sleep. I'm checking, basically, for example, if cryo sleep is 2, then I know the total spending will be 0. So I'm fixing that for cryo sleep 2. I'm doing the same for training and test. Then, for example, my train data, I'm dropping passenger ID, cabin, and name. I don't need that. Basically, passenger ID, cabin, and they will add extra noise. They are not important for my learning. So I'm dropping these. Then you can see with all the engineered features and the features removed, this is my final data. Then again, I do our info to see everything once again. Everything looks fine. Then what I do next is basically uh, convert the types. Basically, I'm getting, now I'm converting all the data types to the correct types. As you can see, I'm doing all the object types to category type, basic class type, all category for all the columns. I'm selecting types that are object and converting them into category type. Same I'm doing for test data. Next, I will see the info again to see everything is correct. I can see everything is correct. My transported is bool, basically true or false, as that is my target feature. I want to see if people have been transported to another dimension or not. That is the goal of the competition. Next, I'll be working on the null values. As you can see, there are a lot of null values. In terms of the size of the dataset, these are not a lot, but still we have to remove them. So I'll be using KNN imputer, basically based on the nearest neighbor. It will select the value. First, I'm dividing the features into categorical and numerical features. Basic categorical features will be all the features category type, and numerical I'll be getting the features that are not category and known. Then these are my categorical features, these are my numerical features. And categorical features, you can see I have all my categories like home, planet, cryo, sleep, destination, VIP, etc. etc. And in numerical I have age, room service, etc. Next, I have created a function to impute my data so that I can easily impute from my training and test data. I am using encoder. For the encoded data, I am copying my data. Then I am first encoding it using a label encoder. Basically, label encoder, what it does is, depending on the unique values that I have, for example, I have three types of values, so it will name them 1, 2, 3 or 0, 1, 2. So I am using label encoder because KNN imputer works on numerical values. It does not work on categorical values. First, I have to encode them. After that, I impute my categorical and numerical values, and for categorical values I convert them back into categories, as you can see this one. Then I call the function. First, I divide my data into x and y, for example, separating my cost so that I do not convert my target feature. After doing that, I call that upon my test, and then I call that upon my test df also. Then I check for num values. As you can see, all the num values have been filled. Next, I have created label encoder for so that I can do that again for my x labels, because logistic regression also works on numerical values, not categorical values. So I am label encoding my x. Then I am splitting my data into train and test sets. I am keeping test set 0.1 so that because in Kaggle there is public data and private data. So basically I want my model to learn as much as from the public data, so that when I am testing for the competition in the from the private data, my model is well trained. Because there is extra data, so I can keep the test data size minimal so that my model can learn as much as possible. Now I'll be labeling coding all my independent features, because logistic regression works on numerical values, not categorical values. After labeling coding, I've split my data set into training and testing set. Basically, I am keeping test size 0.1 because in Kaggle we have a public data and private data. So uh, I am working on the public data and I'll be tested on the private data for the competition on leaderboard. So I am keeping the test size minimal so that my model can learn from as much data as possible, so that it performs better on the private data. So I am keeping it 0.1 or 10%, basically 90 to 10 is the ratio I am keeping. Next, I am training basic logical regression without any parameter tuning. All the default parameters are utilized. LR is equals to logical regression. Then I fit my training set X and Y, and then I made the prediction, and I'm getting the classification report to see everything. As you can see, the precision is not bad, 0.77, 0.72 standard. Basically, on this standard uh, model, without any hyperparameter tuning, every default value we are getting good response, good value. Next, we will perform hyperparameter tuning to improve on our accuracy. The parameters we have are C, the solver, penalty, max iter, class weight. Now we will perform hyperparameterized tuning to improve our accuracy. Basically, I am using Grid Search CV to improve on my model. Basically, what Grid Search CV does, it calculates all the possibilities of the parameters that I have given it. For example, C, solver, penalty, max iterations, class weight, etc. So basically, all the combinations are tested, and I get the best parameters, and my model is trained on those parameters, and then I get the best parameterized model on the basis of accuracy. Default is accuracy. You can give other measures for performance, basically which uh, combination performs better. The default is accuracy. I'm using that. Similarly, it fits itself as the default value is true. If you make it false, then you will have to retrain another model on the best parameters that you get. Basically, we have C solver penalty max attack class width. What the C is, C controls the regularization. Smaller the value is, the more regularization will be performed. Similarly, solver is the optimization algorithm utilized. Penalty is L1, L2, elasticnet. These are different penalty parameters, max iterations, how many iterations will you perform, 10, 50, 100. Class width, basically when class width is none, every features get weight 1, that in case of balance on the basis of the target variable y, the weights are balanced. So we'll perform grid search CV, logical regression is used. These are the parameters we are using. CV, basically we have 5. So what CV is our data set is divided into 5 stacks, and we'll perform cross validation and get our best parameters. Njobs -1 is basically we're using all the threads on our CPU available. So I'm fitting my grid search fit to my training data, and after it runs, I'm getting the best parameters and the best score. Basically for C 0.01 class width balance max at 100 penalty L2 solver is Newton CG. I'm getting the best score, which is 0.79. So you can see from 0.77, or basically average, we are getting 0.79, which is pretty good. And as you will see the leaderboard, 0.79 is not bad for a basic logic regression model. I have not done a lot. I could have used neural network or fancy algorithms, but using basic logic regression I'm getting pretty good score. So now I do the same for test data, and then I make prediction based on test data and make my submission data frame. You have to make a submission CVSV file which you submit for the competition. So here it is. You can see that this is it. We are getting our passenger ID, and for that we are getting transport know the prediction. Basically, now based on this and on the private data, after submitting the code, I will be evaluated, and out of I just 2500 submissions, I am somewhere of 1300, which is not bad. The best people are doing is around 80% around accuracy. Very few people have 90 plus. So this is not bad for basic logical regression. There's not much preprocessing. So I have tried to keep it simple for everyone who is new to machine learning and is trying to uh, solve problems and is not sure. So basically, you can follow along and take help from this to understand how to perform or basically train a model on the given data. Thank you. You can get the links for the competition and this notebook in the description. I hope you enjoyed the video. You had a lot to learn. Thank you for watching, and please subscribe and like the video.